alkanes. We have already had some idea about alkanes in our previous videos. For this year, board has omitted the laboratory preparation and other preparations of alkanes and uses of alkanes. The other things which are there, I am going to continue with the lesson. So, what are alkanes? Alkanes are the hydrocarbons in which all the bonds are single covalent bond between the carbon atom, and they are known as saturated hydrocarbons. And why they are known as saturated hydrocarbons? Because all the 4 valencies of carbon is fulfilled. All the 4 valencies. This is methane. So, all the 4 valencies are saturated. Now, what is the general formula? With this we have already done CnH2n plus 2. So, another property of alkanes is that all the alkanes will undergo the combustion in presence of oxygen to give water and carbon dioxide. They are flammable, that means they catch fire easily, and that is why they make a good fuel. For example, methane is a principal component of natural gas and butane is common lighter fluid. These hydrocarbons are unreactive under ordinary conditions, so they are also known as paraffins, that is little affinity. So, they do not react, unreactive because of saturated bonds. Now, from where do you get these alkanes? So, the sources of alkanes is natural gas and petroleum. What are natural gas? They are the mixture of the alkanes, that is methane, butane and hydrogen, carbon dioxide, carbon monoxide. So, they are principal source of alkanes because they contain, and petroleum. Petroleum is that oil, that crude oil from which all these gases come out, and natural gases mainly contain methane and small amount of ethane, propane and butane. So, let us see the homologous series of alkanes. First member is methane, that is CH4. This is the structural formula, this is the condensed formula, and then next member will be C2H6 like this, and then it is the abbreviated or condensed formula. Then this is C3H8, this is condensed like this, CH3 here, then CH2, then CH3. So, CH3, CH2 and CH3. So, this way this series goes on. So, this is hexane. Let us see the isomerism in alkane. Isomerism, in the last video I have explained that what is isomerism. It is the same molecular formula, but different representations. The first isomerism is butane. Now, butane has 4 carbon atoms, as you can see on the screen. It has got 4 carbon atoms, and these 4 carbon atoms are arranged in 2 ways. This is the first way and this is the second way. First way, all this is straight chain and this is C4H10. In the second method, 1 carbon goes down and thus forms isobutane. Molecular formula remains same, that is C4H10, but the representation changes, and this is the example of chain isomerism, because here one is straight chain and one carbon goes down. So, now this is N-butane, this is N-butane where N stands for normal, and this is isobutane where iso stands for that at least 1 carbon atom is attached to 3 other carbon atom. This 1 carbon should be attached with 1, 2 and at least 3, then it makes isobutane. Next example is isomerism in pentane, that is C5H12. The formula is C5 normal pentane, isopentane, neopentane. They are represented in 3 different ways. So, they form 3 isomers. So, pentane can form 3 isomers. First one we will see, it is normal pentane. This is normal pentane, and the common name is N-pentane, and the IUPAC name is pentane. So, N means normal, that is carbon atom is attached to at least maximum 2 carbon atoms in a straight chain. Then comes the second one, which is in which 1 carbon is attached to, is gone out of the chain, and the common name is isopentane, and IUPAC name will be That is 1, 2, 3, 4. So on second methyl group is there. So 2 methyl and chain of carbon is 4, that is butane. So this is the IUPAC name for isopentane, 2-methyl butane. Iso, you all know what is iso. Iso is one carbon atom is attached to 3 other carbon atoms. Now comes the third one, neopentane. Now neopentane, as you can see, 2 carbon have gone down to the this thing. So neo stands for at least 1 carbon atom is attached to the 4 carbon atom, 1, 2, 3 and 4, then it forms neo. So what is neo? Neo is at least 1 carbon atom attached to 4 other carbon atoms, then it is neo. Common name is neopentane, but what would be the IUPAC name? Let's see, let's name it 1, 2, 3. On 2 place there are 2 methyl. So how you will say it, comma 2, comma 2 and then dimethyl, and carbon chain is 3. So it will be methane, ethane and propane. So it will be dimethyl propane is the IUPAC name for neopentane. Okay, let's see the occurrence of methane and ethane. So occurrence of methane is as marsh gas. तो marsh gas का मतलब है methane. Marsh gas is formed at the bottom of the marshes, and how it is formed? Due to the fermentation of cellulose by special type of bacteria. And what is cellulose? It is found in plants and grass. So when this grass or plants die, they get fermented by the special type of bacteria and they produce a gas which is known as marsh gas. And why it is known as marsh gas? Because it is made in the marshy area, marshy land, and marshy land means where water gets logged, that kind of land. So the second occurrence is it is also present in the air exhaled by animals who eat cellulose. Grass eating animals, plant eating animals. Then it is contained in intestinal gases in the blood of animals and human beings. Then in coal mines, and it is called as fire damp. So when in a coal mine there are some cavities which are created by the gas, and these cavities contain 90% methane. Okay, 90% methane is there in this cavity, and it is called as fire damp. Then it is produced by the dry distillation of wood and coal. Dry distillation means heating it. So when you heat wood or coal, methane is produced, and which coal? Especially there is a variety of coal known as peat. So when you heat that, when you burn it, then methane is produced. Then ethane is always present with methane, and the percentage is 10 to 20%. It is always present along with methane. Now one more thing, that methane traps or absorbs the outgoing heat radiations from the earth, and thus it is a greenhouse gas. Methane is also greenhouse gas because it brings greenhouse effect by trapping the earth's radiation from going out of the atmosphere. And it can remain in the atmosphere for approximately 10 years. See, it can remain there in the atmosphere for 10 years, and it is 20 times more effective in trapping heat in comparison to carbon dioxide. So whatever is the capacity of carbon dioxide to trap the heat, methane will trap it 20 more times in comparison to carbon dioxide. So it is, so after knowing all these side effects of methane, you must understand that it is a very good energy source also. It gives clean fuel. It makes clean fuel because it gives only carbon dioxide and water when heated. So all the alkanes, they will give you carbon dioxide and water when heated. So they make very good energy source. So if we make efforts to utilize methane properly and prevents its emission, and utilizing those emissions as a fuel, then it can bring lot of economical and environmental benefits. So structure of methane is tetrahedron, and what is the meaning of tetrahedron? It is the pyramid shape. Okay, so it is pyramid shape, tetrahedron, and this is, you can see here, this is the shape of methane molecule. And the reason for this pyramid shape is that the carbon has 4 electrons, and these 4 electrons are repelled by each other to the maximum distance. So, all these 4 electrons will be at the 4 corners of this carbon atom, and thus this bond will be formed, and the distance of all the 4 hydrogen will be equal, and that is why it forms a pyramid shape. So, laboratory preparation of methane and other methods of preparation of methane and ethane is not there in the syllabus for this year, but I will be making a separate video for it, and I will be posting it. So, subscribe so that you come to know whenever that video is uploaded. Now, let us move on to the another topic, that is physical property. Methane is a colorless and odorless gas. Its melting point is this and boiling point is this. It is negligible soluble in water and soluble in organic solvent. As you all know that all the organic substances are soluble in organic solvents. Color ethane, same, colorless, odorless, tasteless and non-poisonous gas. Its melting point is this and boiling point is this. This is sparingly soluble in water, very less soluble in water, but wholly soluble in organic solvents like alcohol, acetone and ether. As you all know, methane and ethane are saturated hydrocarbons, that is all their 4 valencies are, carbons valencies are satisfied, and that is why they do not react with bases like NaOH, and even they do not react with an oxidizing agent as potassium permanganate, or they even do not react with the reducing agent as sodium metal, but they undergo combustion and substitution reaction. Now, all you have to remember these two, that alkanes undergo combustion as well as substitution reaction. I have already given you a brief idea about substitution reaction, but when we will see the examples, we will understand it better. The first example is complete combustion. Now, complete combustion means here complete combustion in the presence of oxygen. Oxygen will be present, that is in air. In air, this complete combustion will take place, and methane and ethane in air, that is in presence of oxygen, burn with bluish non-sooty flame. Same way as आपके घर में जो LPG बर्न होता है, सिलेंडर आपके घर में जो खाना बनता है, दैट सिलेंडर में से जैसे इस तरह से फ्लेम निकलती है, सेम वे मीथेन एंड ईथेन ऑल्सो बर्न, एंड ब्लूइश नॉन सूटी, ब्लू कलर का होता है फ्लेम, और नॉन सूटी मतलब होता है उसमें कोई भी कालिक नहीं निकलती है, काला नहीं होता है. व्हाट इज सूट? सूट इज अनबर्न्ड कार्बन. सूट इज अनबर्न्ड कार्बन. जैसे कैंडल होता है, कैंडल में समटाइम्स यू मस्ट हैव सीन व्हेन candle is burning, you can see black small pieces going in the air, small that flakes, that is unburnt carbon, जिसको हम सूट बोलते हैं. तो जब भी alkanes undergo combustion, they will give a bluish and very non-sooty flame, and the formation will be carbon dioxide and water. जो फॉर्म होंगे, कंपाउंड्स फॉर्म होंगे इसके कंबशन में, वो होंगे आपके सिर्फ कार्बन डाइऑक्साइड एंड वाटर. चाहे इथेन बर्न हो, चाहे मीथेन बर्न हो, चाहे इथेन बर्न हो, बोथ ऑफ देम विल गिव यू द कार्बन डाइऑक्साइड एंड वाटर, एंड प्लस लॉट ऑफ हीट विल बी गिवन आउट. दोनों केसेस में they give lot of heat energy. So large amount of heat is also given out. So alkanes are good gaseous fuel. ठीक है, तो alkanes are good gaseous fuel, and why they are gaseous fuel? Because they give large amount of heat. Delta is the symbol of heat. Now in the year 2020 in the board exams, this question was asked about the complete combustion of ethane, and this reaction was asked. Then combustion in insufficient supply of air. वहाँ भी पिछला जो reaction देखा था, that was insufficient air. But now what happens when they burn in an insufficient supply of air? Then वहाँ पे जो कार्बन डाइऑक्साइड बना था, यहाँ पे कार्बन मोनोऑक्साइड बन जाएगा. ओके, सो और अगर और भी कम ऑक्सीजन है, इससे भी ज़्यादा, तो सिर्फ कार्बन बनेगा, मतलब सूट बनेगा. अनबर्न्ड कार्बन विल बी रिलीज along with water vapor. So these reactions also you have to learn, that in insufficient supply of air, carbon dioxide will not be formed, carbon monoxide will be formed, plus lot of heat, plus lot of. Now this soot which is formed also has use, they are used in manufacturing of printing inks, printing inks, and they are used in the manufacture of tires. So, these are the two uses which is produced by these two uses of soot, which is produced when in very less oxygen, in very less supply of air, alkanes are burned. Then very important chemical properties is substitution reaction. Substitution reaction. Let us see how it goes. So, the substitution reaction, reactions with halogens. So, what are halogens? Halogens are chlorine, bromine, iodine. These halogens, when they react with alkanes, they give substitution reactions, and the products which is formed is known as alkyl halide. Whatever is formed is alkyl halide. Alkyl halide will be formed. So, let us see the first example here. Methane reacts with chlorine in diffused sunlight. Diffuse means directing. So, diffuse means not direct, that is scattered, okay, reflected by some hard substance. So, some rough substance. Then it will be diffuse sunlight, or the temperature should be 600 Kelvin. This is the need of the temperature, either diffuse sunlight or 600 Kelvin. So, then the product will be methyl chloride or chloromethane and HCl. So, let us see how this reaction takes place. Now, this is the structure of methane, that is CH4 plus Cl, which is Cl2, that is this Cl2. I have made it like this. Now, this Cl will join with this H to give HCl, and plus, now this is gone. Now, we have what is left? It is left CH3 and this Cl. So, CH3 and Cl is left. So, chloromethane. Now, this chloromethane is alkyl halide, and halide stands for halogen. And why it is known as substitution reaction? Because this hydrogen which was present here goes, and this chlorine comes and join this place. So, that is why it is a substitution reaction. So, CH3Cl is formed by substitution of hydrogen atom of the methane molecule by this chlorine atom, and this type of reaction is known as substitution reaction. And the product which is formed is known as substitution product. So, chloromethane is substitution product. Now, this substitution product which is present here, chloromethane, it again reacts with chlorine. This chloromethane which was found in the previous slide will now again combine with chlorine to give dichloromethane. चलता ही रहेगा substitution. किस तरीके से? We'll see. So, let's see again that what is formed. This is CH3 and this is Cl, that is CH3Cl. Now, this CH3Cl will again combine with chlorine, and this again will form HCl, and this chlorine will take the place of this hydrogen. So, the structure will become, and the formula will become, so the formula will become CH2Cl2. Now, again this plus chlorine, it will react again, and this will form HCl, and this chlorine will come here. So, the formula will become CHCl3. So, you have seen this way, this CHCl3 will again react with chlorine to give CCl4, that is tetrachloromethane, or it is known as carbon tetrachloride, and plus HCl in every case. This reaction will take place till all the hydrogen are removed from these alkane. सारे हाइड्रोजन जब हटा दिए गए, now it is without hydrogen. Okay, so till then this substitution reaction will be going on. The substitution, one more hydrogen atom and produce dichloromethane, then further produces trichloromethane, and finally tetrachloromethane. And the substitution product can be separated by fractional distillation because of the appreciable differences in their respective boiling points. Now these substituent products which are formed by these substitution reactions, they can be separated by fractional distillation because they all have different, they have good difference between their boiling points. Now ethane also reacts with chlorine the same way. जैसे अभी पीछे हमने देखा था वैसे सेम इथेन भी रिएक्शंस करेंगे और क्या क्या बनाएगी, आपका क्लोरोइथेन बनाएगा, फिर डाइक्लोरोइथेन बनाएगा, ट्राइक्लोरोइथेन बनाएगा, टेट्राक्लोरोइथेन, देन पेंटाक्लोरोइथेन, हेक्साक्लोरोइथेन एंड so on. So you can see here ethane will attach with chlorine and similarly it will form monochloroethane and HCl will be produced. This monochloroethane again will combine with chlorine because there are 6 hydrogen. So there will be 6 steps you can see here every time unless and until the whole hydrogen are removed and we get hexachloroethane. Okay. So this is hexachloroethane and every time the HCl will be produced as a product. So all alkanes react with chlorine, bromine and iodine in the same manner producing the substituted products. Then comes the next chemical property, that is catalytic oxidation of alkanes. What is catalytic oxidation? Oxidation in the presence of catalyst is known as catalytic oxidation. So what does alkane form when they undergo catalytic oxidation? They will form alcohol or aldehyde or carboxylic acid dependent upon the reaction condition. So what we are doing, we are actually converting alkanes into alcohol, aldehydes and carboxylic acid by catalytic oxidation. So we will see the first reaction. Now in this first reaction you can see that mixture of methane and oxygen is taken by 9:1 by volume and it is compressed at this pressure, that is 120 atm. It is compressed and then it is passed over copper tubes. Cu tube लिखा हुआ है ना यहाँ पे, तो ये requirement of the reaction है. तो first reaction हम ये study कर रहे हैं. So this first reaction where we take methane and oxygen in 9:1 ratio, it compressed to 120 atm and it is passed over copper tube at this temperature, that is 475 Kelvin. Methyl alcohol is formed. This is methyl alcohol CH3OH. तो ये reaction आपको याद करना है, how to make methyl alcohol from methane. So this is the reaction and requirement of the reaction is very very important. You have to learn the requirement of the reaction. अगर आपने ये नहीं लिखा तो उसके मार्क्स आपके डिडक्ट हो जाते हैं, ठीक है. This is the requirement of the reaction. So this was the first reaction where we are converting methane with the presence of catalyst, the presence of oxygen, that is we are adding oxygen, oxidation हो रहा है और क्या बन रहा है हमारा methyl alcohol. Now comes the second. So when a mixture of methane and oxygen is passed through heated molybdenum oxide, this mixture is oxidized to formaldehyde. Formaldehyde बन गया आपका, है ना. ये मैं ऑलरेडी बता चुकी हूँ आपको. This is the first member of aldehyde group, वहाँ जहाँ हमने functional group पढ़ा था. And if you have not seen that video, you just see that video, you will understand about the functional group and water will be formed. So this is the alkane converting into formaldehyde or aldehyde. This is the next reaction which we will study now. So here what is happening, methane is oxidized to formic acid. This is formic acid in the presence of manganese based catalyst and 100 degree Celsius. ये जो reaction है ये 100 degree Celsius पे हो रहा है और फॉर्मिक एसिड की फॉर्मेशन हो रही है, दैट इज ओइक एसिड, है ना. फर्स्ट मेंबर कार्बोक्सिलिक एसिड ग्रुप एंड प्लस वाटर विल बी फॉर्म्ड. सिमिलरली इथेन ऑक्सीडाइज टू इधर इथाइल अल्कोहल और एसिटल्डिहाइड और एसिटिक एसिड, ठीक है. तो वो सेम जैसे हम मीथेन का यहाँ पे रिएक्शंस कर रहे हैं, सेम हम इथेन का भी रिएक्शन ऐसे ही होता है. यू कैन सी हियर इथेन इन द प्रेजेंस ऑफ ऑक्सीजन, बिल्कुल सेम जो कंडीशन थी हमारी फर्स्ट वाली, जो फर्स्ट हमने रिएक्शन देखा था ये वाला. यहाँ पे ये जो कंडीशंस थी बिल्कुल सिमिलर कंडीशंस यहाँ पे भी हैं हमारी. इथेन में भी ये रही हमारी सिमिलर कंडीशंस और वहाँ पे हमारा मिथाइल अल्कोहल बन रहा था, यहाँ हमारा इथाइल अल्कोहल बन रहा है. वहाँ पे हमारा फॉर्मल्डिहाइड बन रहा था, यहाँ एसिटल्डिहाइड बन रहा है. और यहाँ पे हमारा फॉर्मिक एसिड बन रहा था और यहाँ हमारा एसिटिक एसिड बन रहा है और सेम रिएक्शन, बस यहाँ पे आपका ये चेंज हो जाएंगी कंडीशंस। यहाँ पे आपको प्लैटिनम लेना पड़ेगा कैटलिस्ट और 300 डिग्री सेल्सियस लेना पड़ेगा। इथाइल अल्कोहल इन द प्रेजेंस ऑफ ऑक्सीजन will convert into acetic acid. So this way you can convert methane and ethane into alcohols, aldehydes and carboxylic acid depending upon the condition. Okay, so now we'll see that whether through the process known as slow combustion, whether alkanes can be converted to alcohols, aldehydes, carboxylic acid or not. As you know, alkane is a saturated hydrocarbons, so they are paraffins, they react very less, but here what they have done, they have made the conditions as such that they have used high pressure and very low temperature. So at high pressure and at low temperature in the presence of oxidizing agent, although but alkane will be converted to alcohol and alcohol will be converted to aldehyde, and then aldehyde further oxidized will form carboxylic acid, and finally the final product will be carbon dioxide and water vapor, which you have already studied that the complete combustion of alkanes give you carbon dioxide and water vapor, but it happens step by step. Now with the examples you can see here that methane is converted into methyl alcohol, which is alcohol, then further oxidation will result in formaldehyde, which is aldehyde, and further oxidation will result in formic acid, and later on carbon dioxide and water will be formed. So let's see the mechanism that how this is happening. So I'll show you with example that how this reaction is happening actually. So let's take the first example, that is methane here. So methane, the structure is this, and now we will oxidize it. Now this nascent oxygen actually shows the contribution of oxidizing agent. So oxidizing agent is giving this O and further reaction is happening. This will just go and fix its position here like this, and the compound which will be formed will be HCOH, then H, then H. And what is this? This is methanol. Okay, what is this? This is methanol, and which is alcohol. As you can see the OH group here, and when you see OH group you come to know that this is methanol, or it is also known as methyl alcohol. Condensed formula you can see CH3OH. So this is methyl alcohol. So alcohol is formed with the oxidation of methane. Methane you will make methyl alcohol. After this methyl alcohol is oxidized, what is happening? And again it is oxidized. So what will happen? This O will find 2H and will come out as water, and the thing which is remaining will be, so you can see here it is HCHO, and this is formaldehyde, this is formaldehyde or aldehyde. Now again this formaldehyde will be oxidized, and what we will get? This is again oxidized. Now this O will find place, if hydrogen is there it will come and join here. So we will get, so you can see COOH, that is formic acid, और इसका दूसरा नाम क्या है? मेथेनोइक एसिड. इट्स मेथेनोइक एसिड, या इसको हम बोलते हैं कार्बोक्सिलिक एसिड. एग्जाम्पल ऑफ कार्बोक्सिलिक एसिड. तो यहाँ पे हमने देखा अभी कार्बोक्सिलिक एसिड बन गया है. नाउ फर्दर दिस carboxylic acid will again oxidize. So what will happen and what will be formed? You can, again I told you, if it will have H, this O will try to go and fix in between. तो देखो क्या बनेगा? HOC, then OH, ये आ गया इधर हमारा डबल बॉन्ड O. Now what is this? H2 and CO3. क्या आ गया ये? ये आ गया आपका कार्बोनिक एसिड. ओके, H2CO3, 2H, then C, and then 3O, 1, 2 and 3O, H2CO3, carbonic acid, and carbonic acid on further heating gives you carbon dioxide and water. तो ये पूरा हमारा जो चेन है ये कंप्लीट हो गया हमारा, जिसको बोलते हैं ऑक्सीडेशन या स्लो combustion. So ultimately this slow combustion will give you कार्बन डाइऑक्साइड एंड वाटर वेपर. ठीक है, तो इस तरीके से ये आपकी साइकिल कंप्लीट होती है. लेकिन ये होगा कब? जब हाई प्रेशर और लो टेम्परेचर पे हम ये कंबशन करेंगे, तो ऑक्सीडाइजिंग एजेंट की प्रेजेंस में कंडीशन होगी. सेम वे जैसे हमने मीथेन का एग्जांपल दिया है, अदर अल्केन्स आल्सो फॉर्म सिमिलर प्रोडक्ट्स व्हेन दे रिएक्ट विद ऑक्सीडाइजिंग एजेंट. ओके, so thus we complete the topic alkanes.